Hey everybody, another day, another LeetCode problem. So let's go to the second problem in the graphs playlist. So this is 695, maximum area of an island. So if you were following through the playlist, and the last question was actually LeetCode 200, which was total number of islands. So yeah, this is just an extension of that. Basically the code, everything is very much the same with a little tweak. So again, we're given an end-to-end binary matrix. 1 corresponds to land and 0 corresponds to water. So we need to find the islands. And so we're not really counting the number of islands here. We're looking for the maximum area of an island. So yeah, if we look at this, we can see the size is 1, the size is 4, this is 5, 4, and this one over here is actually, what is it, 4, 5, 6. Yeah. And then we have another 5 again. So the answer is actually 6. So I think it's very simple. If you guys saw that one, so there's very little extra to do here. But again, let me just go ahead and kind of explain it. Okay, so let's look at the islands over here. So this, what is this? This here is an island. You can see this is an island, this is an island, and this is an island. So I have 4 islands, and as I can see, this one is the biggest with at the size of 7 over here. So again, I'm going to go ahead and follow a DFS because every time I start from an island, I want to keep a visited set. I'm going to start from the island. I'm going to go ahead and conquer the island, but in this one, instead of just going ahead and like traversing it, I also want to add like a unit value each time I find a new uncovered piece of that island. So I'll go on adding that, and when I probably come to a value which has no like unvisited valid land neighbors anymore, I can just return like the area to be just the area of this, or 0. So we're going to have a base case for that if its neighbor is already visited or it's either out of bounds, then I just want to return 0 because that's not a valid contribution. But if it is something like this, then this would return 1, but its neighbors are all zeros. So they would be returning a 0. And in this case, let's say from this one, if I go this side, it's out of bounds again, that returns 0. So yeah, basically we're going to do the same a DFS recursion, and we're going to be adding values back. So I think it's more intuitive if I just code it up. I think that would be a better way to understand it. So again, I like going ahead and just mentioning these values. Okay, so sorry, if the grid doesn't exist itself, then we can just return 0. Now I want to go ahead and like keep a visited set, which is very important. So I want to define what is this function going to be? Find area. Let's see. So this is going to find the area of that specific island. So we're going to take rent to column. Let's write this later. But initially what happens is I'm going to start from each cell, see if it's not visited and it's a piece of land. So that's 1. Then I'm going to go ahead and find the area of the whole island, the connected island over there. So I'm going to do range rows, see columns. It should not be visited. I keep spelling this wrong. And it also needs to be a piece of land. So yeah, it's given 1 here. Then I can go ahead and so our main objective here is to find the maximum area, right? So maximum area is, let it be 0 by default. So we're gonna compare this with all the other island areas that we find. So maximum of max area, comma, find area, the function itself. So this function is going to have to return an area of that island, RC. So we can go ahead and just return max area. Okay, so let's write this function now. One thing, as I mentioned, the base case is that if we go out of bounds or we find something that's already visited, then its contribution is actually 0. So I can go ahead and write that if r is less than 0, greater than or equal to rows, c less than 0, or c greater than equal to columns. Or what was the other condition? Or R and C is in visited, visited, then I want to return a 0. Okay. Or else I want to go ahead and I want to visit it. Visited, we'll add this coordinate, and also I need to have an area. So by default, I know that this is a valid, it's a valid piece of land already. So I know that by default that corresponds to that, whether or not it has neighbors, it contributes 1. So that's 1 over there. I want to mention the directions. We have 4 directions, which they mention is the way that these islands connect. So I'll just go ahead and 0, minus 1. Okay. So my row and column would be equal to this. Okay, adding those values, then I want to check. So if they are in bounds, so equal to rows, less than rows, 0 less than or equal to column, columns, and what else? And row column not invisited. You know what? Actually, I'm writing that as a base case here, right? So I'm going to check it. So let's not write it again here. Let's just write and grid of row column is equal to 1. Then what I want to do, I know that this is probably that neighbor is going to add back to it. Yeah, so we can go ahead and write that as, so I'm checking if it's in bounds and I'm checking if it's contributing 1. All right, yeah. So then I want to go ahead and add that. So area, my existing area will be added by whatever area my neighboring cells are returning. So find area of row column. Okay, and at the end of this, I can return area. So this will have the value of the total island area that we were talking about. So yeah, I hope this is correct. Let's just run it and see. Okay, it works well. I did not make any typos this time, so. Okay, and as we can see, again, similarly, the time complexity here is going to be O of m n to n times 4, but dropping constants, so m n to n. And our space complexity, so we have a visited set, which would have m times n different coordinates, so that's m n to n. And then we have a DFS function over here, which is recursive. And actually, at max, if you go to 1 depth, that would be something like max of m comma n. So we have this for our visited set. And then we're going to have a max of m or n. But if we look at the dominating term here, it's going to be O of m into n. So yeah, that is the time and space complexity. And as we can see, this, yeah, this does work. So I hope you guys understood, and happy coding.